Welcome to the MoTrPAC Data Hub. This website was created by the MoTrPAC Studies Bioinformatics Center at Stanford University. First, some background information on MoTrPAC. MoTrPAC is a large, multi-year, multi-omics, and multi-organism study focused on understanding the biomolecular effects of exercise in an effort to understand how exercise makes us healthier. In this phase of the study, we're specifically interested in the long-term, lasting adaptive training effects, independent of acute exercise effects, using rats as our model organism. Data from rats provides the opportunity to measure tens of thousands of biomolecules in all tissues. Rats were endurance exercise trained on treadmills, and tissue samples were collected at either 1, 2, 4, or 8 weeks of training, with a 48-hour rest or washout period before the samples were collected. Now, to browse this one-of-a-kind dataset, let's check out the MoTrPAC Data Hub. Once greeted by the homepage, there are a number of features to be aware of. The top bar contains links to all the data that you can access. If you're a consortium member, you can log in using the button on the far right. This video will focus on the portion of the portal that is publicly accessible. To interact with the datasets with more granularity, click on the Explore tab. Here, you are greeted with a number of options for exploring the data. Suppose that you were specifically interested in the gene BAG3 and wanted to know more about how exercise training affects this gene or its protein product across tissues. You can head to the Differential Abundance page. This page allows you to search genes, proteins, or metabolites and view their biomolecular changes at each time point in the study, as compared to a non-exercising control. Let's type in BAG3 and search. The resulting table shows summary statistics for changes in BAG3 as measured at each time point for all available tissues, assays, and for both sexes. By clicking the filter options on the left, you can limit the results, perhaps just to the liver, RNA-seq transcript abundance, or just to males. Or you could see attack-seq results for both sexes in all available tissues. If you're interested in summary statistics for a test of an effect of exercise training on a biomolecule at any time point during training, click the Training tab. Suppose you wanted to show the behavior of BAG3 transcript levels in males and females and visually compare heart and liver data. Check out the Gene-centric View. Here, you can browse the summary statistics for the global training effect on a gene of interest, and then graph biomolecular abundance over time. Let's select BAG3 again, and filter to heart and liver, as well as RNA-seq, and check out the plots. MoTrPAC has data on tens of thousands of biomolecules. If you don't have a specific list of genes, proteins, or metabolites of interest, you may prefer to explore clustered results. Check out the Graphical Clustering tab. Graphical clustering groups biomolecules together based on either their change over the course of training or at a particular point of training. In this way, you can learn about the biomolecular features that are upregulated at 8 weeks of training in males and females, or perhaps biomolecules that downregulate at week 1 and stay down for the duration of training in just females. You can interact with the charts in the Graphical Clustering page in far greater detail. To get started, click on the button under the chart or head to the Interactive Data Visualization tab. Take a look at the how-to guide to learn how to take full advantage of this visualization tool. You can perform graphical clustering analysis using tissues and assays you select and adjust the parameters of the graphical clustering. Say you are interested in just the muscular tissues. Select gastrocnemius, heart, and vastus lateralis. These parameters are retained throughout the entire application in the tabs that will be shown next. Then, feel free to customize the trajectory visualization with the features on the right-hand bar. You can also view the compositions of each of the clusters, which are indicated by MoTrPAC-specific nomenclature, shown on the left-hand side. The top 10 clusters are shown by default, and they can be compared by the total number of features in the cluster, the percent of features contributed by each tissue, or by the percent contributed by each ohm. Here, the largest cluster is made of biomolecules upregulated in males and females at every time point. Most of those come from heart, or gastrocnemius tissue, and are largely proteins or RNA transcripts. You can also create feature trajectory graphs for each cluster that was created. Finally, you can pick a specific cluster and see the results of a pathway enrichment analysis graph. Pathways upregulated at 8 weeks in these muscle tissues include carbohydrate metabolism and cellular response to heat stress. The included biomolecules are conveniently listed for you in the interactive network. To learn more about these tools, check out the other documentation and tutorials on the MoTrPAC Data Hub. If you want to perform your own analyses or exploration, head to the Downloads page to download the datasets. Here, you can select specific datasets to download or download our pre-bundled datasets. Our pre-bundled datasets are available grouped by ohm or tissue. If you want to select the specific datasets to download, you can filter datasets by a number of parameters, such as tissue type, assay, and more. You can select any number of files and request to download them. Let's select just the brown adipose ATAC-seq data. To download them, click Select, and then click the Download Selected Files button. Enter your email address and your name, and hit Submit. An email will be sent to you within the hour with your selected files. Finally, the Data Hub provides a number of resources related to the main MoTrPAC rat endurance training paper. You can view a list of all publications produced by members of the MoTrPAC consortium, all the code repositories that MoTrPAC used to process, QC, and analyze the datasets, all the methods used by this phase of the MoTrPAC study, and see related studies. We would like to highlight that the assembly of this extensive and invaluable collection of data has been made feasible by the relentless effort and dedication of every member of the Molecular Transducers of Physical Activity Consortium. We encourage you to visit MoTrPAC.org to learn about the consortium. We hope you enjoy interacting with the website. We welcome and appreciate any and all feedback to make your experience more productive and enjoyable.